Hi, this interesting question that I have taken is about our unit B1 as well as B.2, in which we will find out the equilibrium temperature of the planet. Let's say that planet is Earth. Okay, so we know the radiations are covering a lot of distance from Sun to Earth, that is 150 million kilometers. And according to this question, this distance is the letter D. Okay, so when the radiations are reaching the Earth surface, the intensity or apparent brightness of the light considerably reduces. Okay, so eventually the light that reaches on the surface of Earth is equal to the intensity is power. Okay, power radiated, which is mentioned here in this question. So power radiated divided by the area of this imaginary sphere. Okay, this imaginary sphere which I have drawn, which is passing from the surface of Earth. So power over 4 pi d square. This, you can call it intensity or apparent brightness, both are same thing. Okay, now the point is that when this radiation is reaching the surface, all of them are not absorbed. First of all, some radiation will be reflected directly from atmosphere or from the surface of Earth, and the albedo value is alpha. The albedo of the Earth is alpha. It means that, and what is the albedo? Albedo tells us that how much is the reflected intensity of light to the total incident light. So students, if we put the value, right, so that will be over how much is the incident light, that is a power over 4 pi d square. Okay, so it is important to know that how much is reflected, because it will give us the amount of radiation which are absorbed. Okay, because the thermal equilibrium temperature is actually due to absorbed light, not due to the scattered, not due to the reflected light. So if we find from here, the reflected intensity is equals to alpha power over 4 pi d square. Okay, so it means that if it is reflected, then how much is absorbed? So for this, so students, for this we must subtract this value from the total light intensity that is reaching the Earth's surface. So means that, I mean to say, this was reaching the surface minus the reflected one. So it will give us the light that is hitting, interesting point, that is hitting the surface of Earth. So 1 minus alpha. Now here one important point, this is a total amount of light that is hitting, but remember that this is will not be completely absorbed due to the geometry of the Earth or any planet that is spherical. Okay, so on average, 1/4 of the total area, 1/4 will absorb this light. Okay, and then it will make the temperature. Okay, so students, if I just to show you that this is the area which is going to expose by the light. Okay, otherwise the light will not incident on the rest of the area, and all the light will be absorbed on this part. So this is, as I said, is a 1/4. So I must take 1/4 of the light that is hitting the surface. So this one into 1 minus alpha. So you have seen that I have taken 1/4, so it will become 1 minus alpha into power over 16 pi d square, and finally that is equals to the absorbed intensity, and that will be radiated as well. Okay, so what is the absorbed intensity? According to the Stefan Boltzmann law, we can say E, emissivity of the planet is E. Okay, it's not a black body. Sigma is a constant, and the temperature T raised to power 4. We want to find the temperature, so we have to take the E and sigma on the other side. So that will be 1 minus alpha power over 16 pi d square, and you can take E and sigma on the other side. And as you want to find out the temperature, so you have to take 1/4 on the both sides in order to find that. So that will be obviously then So you can see that I'm taking 1/4. Okay, and 1/4 means that's the fourth cube root, so you can also draw, or I mean you can also write like this. So that's why our right answer should be A. And remember that this the same type of question was I had seen like many times in the paper 2, so it's very important for the paper 2 as well.